So the next section before lunch, all we want to do is standardize the test definition between like 15 frameworks and the build artifacts. Maybe come up with an API for the build artifact API, and then the test execution API. So got an hour and a half. Should be no sweat. So test definitions. So a test definition consists of the things, all the metadata and the instructions that are required to run a test. Okay, so every system has this somewhere, whether it's implicit or explicit. Most people have it explicit. If you have a repository, you have a repository access API. Like I said earlier, it could just be you have test definitions in your file system and you read the stuff out of the file system, but your test definitions live somewhere. They have to. They have to be persistent for you to run a test multiple times. And so what are the elements of that? So some of the issues are, what fields do people have? Why do they have them? Can we somehow interoperate? It would be great if we could allow one system to run tests from another framework, right? So if I could get all of Lava's tests and run them in Fuego, I could get all of Phoronix's tests and run them in Fuego. I would like to get all of OpenTest's tests and run them in Fuego. And I'm not just saying that because I want the world to be a Fuego-centered universe, but like for all of, if we can agree on some standards, then all of us can be running a lot more tests, right? And it won't matter, if we have an interchange, it won't matter what someone chooses to run their test in, right? So, or write their test in. So then the test authorship, you don't have to pick a framework and then commit to that, right? So I'm commoditizing the frameworks, which maybe you have an objection to if you have strong feelings about having your framework win. But, that's not how open source works, right? So, the other issue is, do the execution models prohibit sharing, right? So Lava runs tests quite a bit differently than Fuego does. And the question is it even possible to kind of harmonize that? So I don't know if I have another. Well, okay. I'm not going to. So I don't want to get into the dependencies yet, but I do want to, in the short amount of time we have. So I'm going to describe what Fuego has in terms of a test definition. And I don't think we'll have time to get into the individual fields. Maybe we can start jotting some fields down if there are kind of some interesting ones that are different. But what we have in Fuego is Fuego does a test in a series of phases. And so for each phase, we have a set of shell instructions that we execute. And so those are all contained in essentially a shell script. Although it's a little bit more complicated because we support kind of this weird object-oriented thing that we've built ourselves. And then, so that's for the different phases, like the build phase, the deploy phase. Well, we have the test program installation phase, which we don't have a separate word for, but and then we have the actual execution of tests. But we also have, as part of that, we have dependencies. So we have a set of, and we use just shell variables for that. So we can say, I need 2 gig of RAM, I need root permissions, I need this kernel config in order to run. So we have dependency information. Also, as part of the test definition, we have the pass criteria. For us, that's in a JSON file, and it says, for this particular test, this many entries have to pass, or these particular tests are allowed to fail. We have something called chart config, which is our visualization layer. So we have whether to format the data as an HTML table or as a graph over time. And so there's visualization aspects. We don't have anything, well, I won't talk about what we don't have. And then the other major area that we have is we have essentially kind of a manifest file that says who's the maintainer of the test, what's the version of the test, what version of Fuego does it work with, where did the test source come from? Yeah.
Are you talking about a test? Are you talking about a test or a test suite? Because there's a strong distinction between the two.
Well,
you're wrapping a test suite, right?
Fuego doesn't make for us a test could be. Well, I don't know. So what's your distinction? Because I'm not sure.
Well, to use your example, LTP versus a particular LTP test like audit. OT
we have tests. Our notion of test covers both of those use cases. So we actually have tests that do individual LTP tests, and we have tests that run the entire LTP suite. And we have what we call specs that allow us to run like the syscalls portion of LTP or the POSIX portion of LTP. And so we actually have 3 different levels of tests that wrap LTP. Does that answer your question?
Yeah, I think so. I'm trying to map it to what we have
Okay.
For defining our tests that we run in Lava. Because Lava doesn't define the test, but Lava has an interface for how you can define a test. And so we have a repo called Test Definitions, which is very similar, I think, to Fuego Core. It's just directories, and each directory is a test suite with like a shell script that wraps it, and then a way to interface with Lava, so Lava knows how to run it also. And it describes the dependencies, and it describes how to parse the results and all that stuff. So it's very similar, I think.
I actually think there's a lot of similarities between Lava, except when you get down to some of the details. Like my understanding is that Lava, there's a set of instructions, but they're run line by line. And actually, I believe what you guys do is you take that list of instructions and create a shell script that you put on the target. Is that right? Okay, so that's not too different. I mean, we have, well, here's the difference. We don't, we have a function, a shell function called test run. Is that right? Is that the right name? I can't remember. And inside that function, we have a bunch of instructions, but they all run on host. And some of the instructions can be execute this next piece on target. So
for us, the Lava part is abstracted though, and I think that Fuego and when I say we, I'm talking about like what LKFT does with Lava, could be shared in terms of how the tests are wrapped and defined and parsed.
Right.
And the Lava thing is one layer of abstraction above that. So the Lava abstraction can just use that, just as Fuego can just use that.
Right. Okay. So. So I think the last thing, there was one other thing. What do we have? We have, the specs. Yeah, so we call it specs, but I'm going to use the variant terminology. And actually, I've been meaning to possibly do a big rename in Fuego. But anyway, that's a long story. So we have the variants defined in a JSON file, and that you can select. Like if you're running LTP and you want to run the syscalls portion, you indicate that, or you want to run the memory or there's a whole bunch of. I guess I don't know what you consider in LTP. How do you consider what do you call those? The different. I don't know. You have the word scenario. You have the word.
Well, basically it's a mess, but there are run test files, there are a set of individual test cases, and then there are scenarios. These are sets of the run test files.
Okay, so the thing that we have in Fuego that's similar to that is what we call a plan, which is you can list a bunch of tests that are going to run, going to be triggered at the same time. And I don't know, does Lava have that notion of like a set of tests that get triggered simultaneously?
Yes and no. We implement it.
I would say no. Lava doesn't. LKFT does.
Yeah, LKFT does. Lava doesn't, is what Matt said.
Okay.
And I agree. We have a test plan notion in the same test definitions repository where you can define the list of test suites and how to run each of those in terms of which tests to run. And we also implement things like skip logic there so that you can skip tests even in frameworks that don't support the notion of skips.
Yeah.
The approach that is widely used at Google and in other projects, and I think in lots of other projects as well, when the tests are bundled with the code, is that when you want to select some subset of tests, you just give us kind of prefix of the source path. So for example, if you change something in net TCP, you say test net /TCP/3 dots. That will run all of the tests in those related to that code.
Okay.
Or
So
you
it's
can
kind of
say
like a
just
wildcarding
net.
thing?
Yeah, but it's tied to the source code organization. So you say test drivers USB something.
So is
or-
each test in its own directory?
It's with the source code. So basically, the driver will select all of the tests that are contained in those paths that you specify.
Okay, so do you guys run LTP?
No,
No.
that's for other projects. How
Okay.
things are done in Google, in Chrome, and in I think lots of other projects.
Okay.
It just it's makes it much more easier for developers. So when you change something in the net, IPv4, what tests you want to run? You want to run the test net /IPv4/3 dots. That will
Okay.
just run everything.
Oh, that's interesting.
Because if you have if the tests are not tied to the source code, then and you change a particular file, how do you figure out what are the names of the test suites that you need to run?
Right. That goes to discoverability, right?
Yeah,
So
Yeah.
But are those what you're calling, are those unit tests or runtime ones?
Both.
Yeah, so I think what we're trying to discuss here is the tests that are not tied to the source code.
But was this already discussed? Because so I have a strong kind of opinion that tests should be tied to the source code and be in the kernel
well, like
code base.
LM Bench. I mean, do you guys run LM Bench or IOZone or NetPerf or? I guess I don't understand what you're. So there's all kinds of tests that are outside the source code that you would run on a system.
Yeah, and they should be
Functional
moved
tests.
to the kernel source tree.
Well,
No.
But
Levels. I mean, there are different levels. I mean, you can have your applications or certain libraries or whatever else that ship their own tests, right? That is part of the source code. But there are more general tests like LM Bench or
what is LM Bench?
it's a CPU benchmark test. Yeah, it's a hardware test.
So there are different levels, and
Well, so
Yeah.
like there's a test of I can't remember the name of it, but there's a test of X performance, right? There's an X benchmark test, and it's not included in the X repository, right? So it wouldn't go along with the X source code. It tests stuff like how fast does this how many frames per second in terms of like a game can X run. So it's kind of outside the scope of what X itself would do. But so there's all this test software that exists outside of source code.
But at least all of the LCP tests, XFS tests, all of the networking tests, they can be tied to the source code.
Well, XFS is not in the kernel tree.
But
right?
it should be there.
Well,
So
But
to me,
we have to deal with the world as it is, not as it should be, though.
But we're talking about like the ability to move tests, right, and share the tests and share them somewhere. Because if they're not there, then the test process stays separate from the development process, and we continue to have tens of thousands of bugs in each release. Then
But-
all forks will need to
Yeah, but-
find and
but you're
fix
looking only at the
separate
model of where what you're testing is only this one monolithic thing. So for Yocto project, we're testing thousands and thousands of things. So those test definitions have to be able to let me know where do I go to get the test for LS or for whatever the heck I'm testing, whatever other sub thing I'm testing. So when you start going to testing at operating system level, which is where I'm at, the functional testing is testing all kinds of things. I've got tests that have nothing to do with the software underneath it because I'm testing it between components.
It's like integration testing.
Yes.
Okay.
Exactly.
Okay.
And
but
also, to me, this part of this needs to have the even higher level because, can I go get the tests from, which Git repo do I pull them from?
Oh, yeah.
And which directory is it in? And I don't mean the test definitions. I mean literally the tests themselves.
Right. Yeah. Part of our test definition can be a tarball or a Git reference, right? And commit ID, right? So.
Okay, there can be some that are separate, but the majority should be in kernel.
No, I'm
That-
gonna
that's
I'm not
our
testing
only
only
have
the
to
kernel.
respectfully disagree.
I'm not testing only the kernel. I'm testing all kinds of user space applications.
Okay, I'm not saying that there must not be tests outside of the tree. I'm saying that the majority should be in tree because.
Yeah, I think.
But the LTP, XFS test, that all tests in the particular parts of the kernel source code, like this test in the X4, this test in the.
I think you
IP.
could probably make a case to TED to put XFS tests in the kernel, but I don't LTP has POSIX in it, which is actually useful to run on BSD and on Windows. So
Actually, they run most of the LTP on Windows these days because they have this Linux subsystem for Windows.
Right.
And it was so strange to see they are basically telling me I did a good job on the Microsoft blog.
yeah, so I mean, there are tests that we're talking about here that I want to run on NutX, right? So.
Okay, but so if we have a common format, then
Right.
one of the repositories for those tests should be also the kernel tree because we want a fix for a bug, add a regression test, and patch with the new functionality, add a test for that
Yeah.
functionality.
No, I think for what you're talking about, I think K-self-test is the answer. That people ought to
but
be.
then they should be integratable into everything that
Oh,
we're
yeah.
discussing.
No, I think we ought to talk about how, as tests are added to K-self-test, right, what fields do they have, what's the format of their test definition, and how we can make interchange and how we can support all of it.
Basically, I see that in the different light. It does not really matter if it's in the kernel repository or somewhere. It's more about the processes around the testing.
Right.
So if you are required to write a regression test, it does not matter if it goes to K-self-test or LTP, but if
Right.
you are required to that, it will change basically the way we develop the kernel. Because at this point, nobody requires you to write regression test for kernel. We are trying
Right.
to catch up in LTP. We are trying to fish for the commits that have reproducers in kernel tree and write test cases based on that. But it's kind of backwards at this point.
Yeah.
Yes, and you can't possibly do that because there are 5,000 people pushing in the code as fast as possible.
Yeah,
so
yeah,
yeah,
if
yeah.
you have few people on the side, they can't possibly do this.
Well, but next year we're going to finish the kernel, so then we'll focus on testing. No.
So
Sorry. Okay, so yeah, go ahead.
I was got a slightly different perspective on this from the Octo project because we've been trying over a period of time to be able to pull in these tests from different projects and actually run them, which is the key
Right.
thing that we want to do. We want to know that the images we build with the Octo project actually work. We've primarily done that from a software perspective. Testing hardware is it's something we definitely need to do, but that's a step down the road and it's generally harder. But we have had experience trying to sort of consume some of these different sort of test projects, such as LTP, which we run. We run the K-self-test stuff that's been developed more recently. And you're focusing here on the test definitions, but there are some sort of parameters to some of these sort of test suites that make it easier for us to be able to consume them. And that's things like being able to...
I feel like I should write something down.
So yeah, well, it's being able to sort of run things remotely. So you can build, you have the build tree, and you have the thing that you're building. We have a cross-compile environment, so it's being able to extract the tests out and then run them separately. So being able to do that is key. It's also about dependencies, because if you've got Groovy or something in there, that's never going to work for us because we don't have that on target or whatever. So simple sets of dependencies is key.
Okay.
And an output format that we can actually just pass into our p-test output and then integrate into the system. So for me...
We'll get to output format.
Well, yeah, no. But what I mean is that there's those sort of... If you do those three things, you've got a sensible small number of dependencies.
Okay, was dependencies, what was the first one you said?
I've lost it.
No, did it have to do with cross-compilation?
Yeah, being able to separate out the sort of the build
The
and then
build
be able to run
instructions?
it remotely effectively. So running, it's the run remotely.
Run remotely. So do you mean the, what I would call the packaging or the bundling?
Yeah, you're
Because
able
you
to
have to transfer that.
right. You're able to put them into some sort of form and transfer them to the remote system. So the remote system is different from the build system. That's what I'm saying.
Don't require the entire source tree.
Yes. Yeah. What I don't want
For
to
the test?
yes. So what I
Right.
don't want to do is to be able to run, say, k-self-test. I don't
Well-
want to transfer the whole kernel source tree to the target.
Right, so case in point, right? So this is something, like BusyBox has a really nice self-test suite, but it requires the BusyBox source to run. And it's like, well, I don't have BusyBox source on my device under test, so it's like kind of goofy. And it's obnoxious, right? That's the reason we don't have, we had to write a BusyBox test from scratch instead of just use the existing self-test. So I think I got what you-
that's where we're sort of trying to go. But if you try and do those things, it makes it easier for us to be able to integrate them.
Right.
And then the final one was the output piece, which, yeah, output format, test results.
Okay.
But a lot
So-
of these things are separate issues, right? There's not necessarily one test definition which says get it from here. These are the dependencies. This is how you build. This is how you run.
Right.
Those are very separate things.
Well, so let's. Well, did you have more you wanted to say, or I don't
Well, I
want to?
just want to give the example. We run a lot of image tests, but some are built with Yocto, some are built with Debian. Sometimes the image has the test already installed. Sometimes we have read-only actual product file systems, so we need to copy the binaries over. Those are all different things. The only thing there which is important for the test definition is how we run the test and get the results out. Everything else is separate metadata that's either packaging or a separate Jenkins build job.
Okay. Yeah.
So, can I write something
Yeah.
more? I think we have, I think our solution right now solve some of the problems you guys are discussing. Is not perfect, but it might help drive the conversation a little bit.
Okay.
So, I don't know if you will be able to read this from the back, but so first of all, we separate the problem in two different parts. On one hand, we have what we call software assets, or you can also call this build description. And here you will put, if
Do we have another pen? It's just there's a green one.
Yeah, that pen's not that good. Yeah, just throw it. I could also take notes or something.
this one, I don't know if.
Yes, better. Thank you.
So we call that software assets or build description, okay? And just to put it a little bit more concrete, if we're testing kernel or Yocto, things you will find here are your kernel, your root file system, and your DTVs, whatever you need to provision and boot and run your test. Now, in this thing, as part of the software assets, you might have a set or a collection of assets, and each of them has a name, and it has a type, and some information that is relevant to this type. Or this information, it kind of tells this type how you're gonna build that asset, that kernel. So to make it a little bit more concrete, let's say you are building outside your test framework using Jenkins. So you already have a kernel that is somewhere in a URL, right? In that case, you will put something like kernel is HTTP, and then here you put your URL to whatever is your kernel image is, right? So in this case, you are just gonna prefetch this image that you built, and that will be your kernel. But if you are building the kernel using Yocto, you could then make this kernel equal, and then you will pass whatever information you need to pass to Yocto to build that kernel asset. So these types, we call them build execution engines. That's the generic term. But in essence, what you are doing when you define your assets is you are defining everything that you need, and you are defining how you are going to build that, each of those components, right? And if you don't build, again, you can use an HTTP build execution engine that is just fetching from somewhere. But this could be something else. This could be your Yocto engine that you're passing parameters that tells that Yocto engine how to build the kernel. So that's just for the software assets or the build description part. Now, when we talk about the test case itself, we have what we call the test execution engine type. This is part of our test case definition. And here you can think of things like Lava or BATF, which is one of the open test execution engines, or it could be Fuego, or it could be whatever execution engine you want to use. So, but something important is that we make that test case definition. What this allows to do is to have a test plan where we can have some tests coming from Lava, some tests coming from Fuego, some tests coming from BATF. And this is something that we have today, right? We have the test execution engine logic, or some people might call this script. And here you're pointing to, basically usually is either a full path or a relative path to your test script. So again, for Lava, you will point to the JSON file that describes your test case. In Fuego, I don't know, it will be your test scripts that triggers the whole thing, etc. Then we have test params. And then these test parameters are specific to this script that you're running, right? So it's, again, depending on which framework and which script you're running, then you will have relevant parameters that this particular script understands and expects.
So the test parameters is how a tester using your system controls, customizes the test for your particular lab or board or whatever. So you use that to customize. So the test parameter gets injected into whatever the script, right, as an environment variable, or the mechanism doesn't matter. So I would consider that your version of variant, right? That's how you're customizing the script for your system. Okay, so I'm just
not customizing the script for the system, because
not modifying the script, but you're customizing how it runs.
Exactly. So the script might be a little bit generic.
Right.
For instance, let's say you have a script that runs how to run USB tests.
Right.
And then in some particular test case, you might run 100 iterations because it's a stress test.
Right.
In another one, you just want to run a couple of iterations, right?
Yeah.
But it's a stuff that the script understands. So it follows. So you are going from very generic, the type of framework, to the actual script in that framework, to the params in that script.
Right.
So you're going from the generic to the specific.
Right.
Here we also have something called, we call it hardware requirements or hardware assets.
Okay. So that's a dependency.
And this is, exactly, so this is the dependencies or tags in Lava. So here is where you're saying, to run this particular test case, I need, and we call it DUT, here we call it DUT1, DUT2, DUT3. The type of DUTs you will put in your build description that allow you to reuse the same test cases across different boards.
Right. So,
but essentially you can call these as hardware dependencies.
Right. Okay. Do you have any visualization in there?
What do you mean by
Do
visualization?
you have anything that describes how the test case results should be presented to the user?
Yeah, so, I mean, in the test case definition itself?
Well, yeah, it's part of the test case definition, right? So you have a test case. Do you say whether you should do a plot or a graph or an HTML chart or?
No, it's not.
Oh, okay.
That's not embedded in the test case definition. The only thing that we have besides this is what gets consumed by the test automation framework.
Okay.
But we also have here like test description and
Right.
pass-fail criteria.
Okay, so
You know, but this is also for human consumption, right?
Right,
When you
right.
export this test plan, you can see what each test case is
Right,
about. You can see what the pass-fail criteria is, and then you can see how you're running it.
Okay, thank you. Yeah, so these are the types of, so a lot of similarities.
Are these descriptions public for some of the test cases you guys are running?
Yeah. So right now, we don't have our test plans in a public repository, but there isn't anything really proprietary. If there was a place that we can agree to put all this on,
Okay,
we will be happy to do it.
Right.
And I think
So
that
we
was
definitely,
that was one of the points I wanted to, I guess,
Yeah.
main thing get out of here to agree on a way to share all this information.
I agree. Unfortunately, that's scheduled for our 3:40 session.
And does
And-
the test case definition specify what software set it needs? For example, if the test requires some kernel config,
Yeah.
so you can run it on
Well,
just
so
any
that
kernel.
is an excellent segue to my next slide, which I'm going to go right here. So, because I think, here. Okay, so just real quickly, one of the areas that we've talked about, and this is the only area where I think we're going to drill down. I think just because of time, we're not going to have time to go through all the different fields that people have. I should probably turn this into a presentation again. So let's talk about test dependencies. So how many systems have a way of expressing that a test needs certain things before it can run? Does everyone have that notion somewhere in their system? Okay, so these are the things that I could come up with. So you can require a certain amount of memory. You can require that there are packages that are installed. You can require root permissions. That's actually surprisingly common. You can require specific hardware, a kernel config. I know 0-day has this and Fuego has this. I don't know if other ones do. You can require specific files be present, specific features, and features is kind of the generic, like I can declare a tag saying, this is a BeagleBone, right? And you can say, well, I run on BeagleBones, and then you do just tag matching. So features is kind of a generic method of doing it, but it requires kind of a lot of effort. And one thing would be nice is if we have features, a generic kind of matching mechanism to like USB might be a feature that's not a specific kconfig, but
One of the things. Awesome.
oh, yeah, go ahead.
One of the things that was interesting when I first started using RTCF at Intel is that they actually have like the network or Bluetooth or whatever as a kind of almost a device. So because Zephyr project is what it was designed for, it was testing devices that would be doing Bluetooth. That meant that Bluetooth became a dependency. The Bluetooth network became a dependency.
But not the individual, like a particular Samsung Bluetooth.
No. So what this meant is that in the integration in the lab, so this is where it gets a little bit fuzzy, that those devices had to be within Bluetooth range of each other, kind of thing.
Oh.
But what I'm getting at is there was kind of an unexpected dependency to
Right.
me, but that's because of the way the testing was being done.
So
that
that's
actually turned into.
So that's not a board dependency. That's a lab dependency, right? Or
it
an
actually
external
became
hardware.
a test. It became a test dependency because in this case.
Well, but the test is it's always the test is depending on this thing, but the thing it's not an attribute of the board, right? It's an attribute of the entire environment, right? That it be within a certain number of feet of a Bluetooth
But-
transmitter.
But well, it's no.
It's not a board feature; it's a lab feature.
Well, it's a different concept. So it's yes, it is ultimately defined in the lab, but just the fact that you're saying these two, in order for this test to run, I need two devices and they have to talk over Bluetooth.
Right.
And that was just a slightly different nuance to this than what we normally think about.
Right. No, I think that's interesting.
So who are
Especially
these
the proximity thing, right? It's like you could have a Bluetooth device, but if it's 100 feet away, it doesn't work. If it's 50 feet away, it does.
I think it's similar. We in AGL we have a similar thing. I mean, we want to test CAN, so we need two boards wired up with CAN.
Yeah.
So it's kind of similar to the proximity, but
part of that we've tried to capture with this, right? There's external equipment.
yes,
Right, that you might have a CAN bus analyzer, or you may, there's something, you can have a dependency on basically kind of anything in this box.
and it has a effect on the DOT scheduling or on the test scheduling because
Right,
we
on
need
the
to be
test
able to
scheduling.
select this specific setup.
That's right, the test scheduling has to possibly know, well, that's where it gets really fuzzy. It's like, who knows what's inside the box? Really, only the duct controller knows.
But so in this
so-
special case of these Zephyr tests, right? It is literally in the test definition. What we mean by test definition, it is literally in there.
Well, right. The dependency is expressed in there.
Yeah.
Right. Okay. Yeah.
So who is this aimed at? Is this these dependencies? Do you want the system to automatically check, or is this aimed at integrators as hints? For example, kernel config depends on which image I submit as a test, and I can know that as a tester, and it will be quite useful for me to know if I want to run these LTP tests. That kernel config needs to be there, but it's not something the system can test for me. And packages is the same thing. You can say,
No,
I need to do systemd.
We
Fine,
have.
but that can be a lot of different configuration things.
Yeah. No, so just on kernel config, right? We have this problem in Fuego, which is right. We aren't necessarily involved in the kernel build, and so we don't know where the kernel config is. We had to write some extra infrastructure to handle it could be in /boot on the device under test, or it could be in a kernel build directory somewhere else, or maybe the tester has to actually provide the kernel config so we can do the checking on it. So there are kind of difficult situations where you don't have the information you need, depending on your test model.
So all this information is very useful from an integration point of view, because then I can look at a test suite that I don't really know and say, all right, I need to make sure these things are enabled.
Right. So let me just drill down all the way down to, it would be really handy for all of the test frameworks, I think, if we could decide where is a reliable place to find in the build artifacts the kernel configuration.
You can't.
Yeah, but
Right.
basically that's a problem for LTP itself as well, because there is no standard place where to find out if something is enabled in kernel or not. So we given up or checking the kernel config, and in most of the cases we just try to call the syscall and see if we get unsupported or something like that.
Right. Yeah,
And
this is a problem that like Yocto and kernel CI doesn't have, because they're doing the kernel builds. So it's like, well, you know where your
But even
kernel
if we
config is.
do Yocto-based systems, we might still have test runs on images that are separated from that.
Right. Well, it's
So-
the same. It's like it's almost the exact same thing that I was talking about before with like the BusyBox config. The reason the BusyBox self-tests need the BusyBox source is because it's looking at the config to determine it's doing essentially its own level of dependency checking to see whether it should run certain tests. And so the same type of mechanism that we might use to say, well, here's where you find the kernel config. If the kernel is the software under test, we might be able to make that generic and say, well, here's the config for this other piece of software under test as well. So, but I think that's a key thing, is to note, like kernel config is something that I think everyone needs to know, and we don't all have it. So I'm going to jot that down. So just a sec.
Yeah,
Okay,
Yeah, so
Go
here,
ahead.
so I just try to add something from the 0-day side. Yeah, so in 0-day, sometimes we treat the dependency dynamically. Yeah, take one example, when we run the XF tests, the hardware requirement is something like one hard disk. And this will impact whether we choose to schedule the test or not.
Oh, yeah.
But when the test actually starts, we will make sure the dependency can dynamically met. For example, we need to run the test on the ext4 system, so we will dynamically do the disk format when we run the test.
Oh, okay.
So it's kind of a
Well,
mix,
so that-
yeah,
yeah,
for the
so-
setup and the dependency.
So that kind of falls under the category here of the dependencies. There's different actions you might take, right? You might, for some things, like if a kernel config is missing, you might say, well, this test doesn't apply to this device, right? If I'm missing kconfig USB, then, or config USB, right, I won't run this test. If you're missing X, maybe you can install the X package. That's a bad example. You would never do that, but but you get the, or like maybe you need Python, right? The test program needs Python, and it's okay to install the Python interpreter, run the test, and then deinstall the Python interpreter. But in your case, I think what you're describing is you actually change the status of the machine to match what's required. So in the case of like Phoronix, they will install packages. Well, that's kind of falls under this, but the one he was talking about is doing sudo, right? He actually will interactively ask for the root password during the test execution, so he can change to root level access. And in your case, you're saying that you'll change the status of the machine by creating an ext4 file system
Right, yeah.
on the fly. So the interesting thing about dependencies is that you have some of them. You can't change the status to match, right? If you don't have a USB device, or it's not configured in the kernel. Well, I don't know. You guys that build the kernels, you can do whatever you want, but Fuego doesn't go out and rebuild the kernel with USB support. But most of the time, so you either end up excluding the test or changing the status somehow so that you can run the test. And those are kind of two different operations. I'm not sure if they need to be broken apart. And like one might be a dependency and one is like a change request or something. I don't know in terms of logically how it works.
Yes, I had a question about files. So packages are.
Oh.
You wanted to discuss?
Well,
something more about
Richard's been waiting for a while to.
Yeah, I was just going to mention, we keep talking about BusyBox, and it's actually
Yeah.
a little bit of a success story for something where we worked with an upstream. So you mentioned not being able to use BusyBox because of the issues with the config files and so on.
Right.
You probably could now, because we worked with the upstream, and you can
Oh.
actually just put the test binaries in there and the config file. So if you have the configuration, you have the test binaries, you can run it standalone.
Well, that's good for stuff created by the Octo project, but I'm talking about a Sony phone.
Right, but you still must build that. You still must build that somewhere. And
Well,
so
that's
if you-
true. No, so it'll flow down, and in 5 years I'll be happy. But
Right, but my point is that originally we had the same problem. We couldn't run it at all.
Right.
Now we have this p-test package, which is something we build separately. It's not part of
Right.
our standard image. But if we put that there, we have the right set of artifacts that we can then run the tests.
Right.
So it does come down to this idea of a test definition.
Okay, so how are we doing on time? Terrible. But p-test, this is actually a good segue. So again, we haven't really solved anything here, but hopefully we've discussed a bunch of concepts on test definition, and we're gonna have to take stuff offline and come back either in a future meeting or by email and kind of discuss some more ideas. But you talked about the next thing on our list.
So one more thing
is
on the
build artifacts.
Just one last thing on the kconfig. I mean, a lot of people are just requiring the proc config GZ interface.
Oh, well, yeah, that's one solution, but it doesn't work for everyone.
Right, I
So-
know, but I'm wondering how bad of a problem that is. I mean, is there most solutions that can't use that, or is that good enough for many cases? That's the main thing I'm wondering.
All I know is it's not enabled on a lot of low-end Sony devices. So,
And is it a problem?
what?
Is it a problem that you are missing that configuration?
Yeah.
Why? I mean,
Because we don't
then
have
that's
it.
the fail, right? That's
So
the
then-
fail.
so
It
then
means it's
enable
just-
it.
It's just
Well-
no. I mean, you have a test.
Yeah, so I'll go to the product team in Tokyo and tell them to change their build infrastructure.
No. I'm just
that's
saying. You have. I'm just
That
asking.
happens in some places.
Well, yeah, I know, but it's like in general.
Okay.
Test definitions.
Yeah, it's about test definition. Okay, and you don't have the information. You will run the test for the USB if USB is not enabled, right? It means
Right.
just about the answer or the result from the test what you get, right? It means one thing is it's not a pass or fail. It's also not available, right?
Right.
It means it's not a problem to run the test, right? You simply just don't get the right answer, right?
Well, the fact is there are low-end Sony devices that don't have kconfig on them, and I would actually like to test features on those, and maybe actually even some tests of kernel features that depend on a particular kconfig. So I don't want to. So the normal thing you do if your kconfig is missing, right, is you exclude the test, right? But you're basically telling me, okay, well then just don't test your device.
No, I mean the other option is just that.
But you probably know what should pass, right?
Was it deliberately not included?
Yeah, it was deliberately not included because of memory constraints.
Yeah, so the other option though is that what other
Do you
tests.
realize how big config GZ is? You guys are all dealing with gigabyte machines. I mean, come on, do a 2 meg machine sometime.
But no, but
I think the config USB option is missing.
But okay.
No. Config USB it's configured on. Yes, I know. There's
If it's
other
missing,
ways.
is it missing because it was deliberately missing, or did
No,
they
no, no.
accidentally
No,
leave
not-
it out when
that's
building
not
the
what-
kernel?
No.
In the second case, your test should
Config
fail.
USB is turned on in the kernel, but proc config.gz is gone.
Okay, but you build it somewhere, so you can just
Yes,
save
yes.
the
So,
config
but that's what we're
and
talking
fetch
about.
it
Is
from
there
there.
is there a rendezvous point that we can agree on for where if it's not in proc config gz, where should people be storing it so that as part of build artifacts, which is the next section.
I
That's
guess
why I
I
thought
get
this
that
was a good
this
segue.
nails down to what Carlos presented. Like you have a dependency, and then you have a method to fetch the dependency.
Yeah. So if we could agree that kconfig is part of the build artifacts and we have a standard location where we get it, that would solve my problem. Because then I can go to, especially if there's a standard somewhere, I can go to the Sony division and say, hey, start putting your kconfigs here or something like that. Right now, I mean, and we do, basically, so like when Fuego builds a kernel, we build it in a particular directory and we know that the kconfig resides there. So we can go grab it there. We try to grab it from multiple places, trust me.
And this kind of feeds back into the p-test thing, because with
Right,
p-test, you know, we have a standard user lib p-test sort of package name location where we can put things. So
and
if make install by default puts it there, you don't
Right.
have to ship it with the system. You can ship it as some other artifact,
Right,
but then you
right.
know where to find it.
That's exactly right. And so tell me, I'm going to slide this over and give you the pen. Tell me about p-test. What's it got?
Well, it's actually really quite simple. I mean, you can't put it so much on there, but the idea is that you have a separate sort of make step. So what we originally tried to do was wrap up any software recipe that had a make check. So there's the configure, and then there's the make that everybody runs, and then the make install. Some other recipes have a make check, which basically runs through the system and runs some binaries. The problem is that doesn't run on the remote target.
Right.
It runs during the build process. But some binaries, some projects like BusyBox, allow you to package up that set of tests, put them into the target, and then run them there.
Okay.
So our
just I don't want to interrupt you too much because your stream is good, but just to clarify, the package that's being tested has been modified to support bundling its test materials.
Yes.
Okay.
Some software recipes are obviously better than others.
Right.
And some upstream projects have been very, very receptive to going and figuring out how to do this, others less so. Okay. And I think if there were more standards around being able to do this, that would be a strong argument for other projects to try and adopt this.
Right.
So the concept is to be able to sort of separate out the tests during the build process with a separate make install tests or make some other make target,
Right.
put them somewhere, then you can get them onto the target, run them. Hopefully there's some kind of standard output as well. In some cases, they have these tests, the output's not standard, so we actually have shell scripts that just filter the results.
Right.
Pick your favorite scripting language. And then you can pull the data back. So p-test is in some ways a very simple concept, but it's also quite powerful because it then means you have a standard way of doing this. And it then means if you're trying to compute test dependencies, you know where to go to look for that configuration or other information.
Right. Okay. So, okay, go ahead.
So the p-test runner is just a C program, and it knows where the tests are, and then there's a run p-test or run
p-test
test.
runner, is that something that's on the the
Yes.
host where Yocto is?
Yeah.
Okay.
Well,
It's on the target.
It's on the target.
Oh,
Yeah,
okay.
yeah, it's on the
So
target.
is there a standard location where p-test
Yes.
things show up on target?
Yes.
Okay.
And then there's a run p-test script for each package.
Okay.
A run
Because these things are installed in a standard location and because we install them, each different piece of software that gets put in there can have a separate script which you can run, which runs a set of tests and gives a set of standard output. We then do have a really simple runner script which can then iterate through any of the tests that are installed on a given system and run them all and give you the set of results and connect them up.
Okay.
So it's
Pause for a second because my brain is about to explode. So this is the first time I've thought about actually standardizing something on DUT, that's interesting.
Can we also?
Because I mean, if we had, because Fuego has because when Fuego runs, right, we have a standard method by which where we install places on the target, and but if it was the same as what other people did.
So one problem there is that
refactoring is blowing my mind. Okay.
I'm also testing production images which have a read-only file system.
Oh,
something like the Verity or whatnot. So I deploy the test artifacts later, and they can't be in /user because /user is read-only. So we typically use something on the /var or some other location we can execute from. But these can also differ per test image.
Okay.
So rather than a standard hard-coded location, can we have a standard environment variable or something like that?
In the Yocto project, this is actually configurable in the same way any other directory in the system can be reconfigured, so you can change bindir or libdir.
So maybe the only thing we can standardize is the name of the configuration variable for the path of the...
Well, yeah, no, you need a mechanism in there where the software actually knows how to do this and split it out. It's, if you go back 10 years, most software recipes didn't have a way of standardizing installing into a sysroot.
Right.
So make install wasn't able to do that. Now we need to get the same concept across to people that actually installing the tests. Do it in a separate step, do it into a specified location. I don't really care where that location is.
Right.
We're talking about slightly different things here. So you're thinking about installing in a standard location at build time so you can grab your test binaries and test scripts. I'm more thinking of being able to have more flexibility when I deploy those testings on the target under the actual testing. So I can just say all those test programs are under varlib tests or somewhere.
Well, I think what that means then, though, is if it's a configurable location, if you wanted to use something from, say, a Yocto project build artifact repository, essentially you need relocatability of the p-test artifacts, right?
Right. It's two separate stages. If you can specify at build time, I'd be really happy because it solve a lot of my problems. If it's relocatable as well, that's an added bonus. But yeah.
Yeah. So Fuego has the concept right now. We actually have a build artifact, although it hasn't come out yet. It's in our 1.4 release pending. That we just build tar files, right? And we don't even, I don't think I've added a manifest to it right now. But we know, Fuego knows where to put those in the file systems and to instantiate them for the tests. One of the issues we ran into was there are tests that require specific, like changes in Etsy, right? So we couldn't containerize the test materials completely, right? They had little things out in the rest of the system they needed to modify. So I don't know, do you have any thoughts or?
Yeah, no, we've done that. So the runner script for that particular test may then go and make the changes before the test starts.
Okay, and that's a DUT side.
That's on the device, yeah.
That's on the device.
Yeah, when you're running the script. So it'll make the change, run this thing, and then put it back.
Okay.
Richard, maybe skip this, but you can install the p-test packages at runtime, so they don't have to be built into the image.
Right, right. Yeah.
As long as you have a package feed and a package manager on your
Is
device.
what's the default use case though? Are they most of the time they just bundled in with the regular image?
No, most of the time people like the small images, so it's that Sony problem where you want the device being really stripped down. So most of the time these things aren't actually installed there.
Oh, okay.
But it's very, very easy to take your standard image and then build a testing image which has the same thing, plus the p-tests, or you could install them at runtime. You've got whatever options. And you don't even need a package manager there. I mean, you could do it with tarballs just as easily. We've not done it, but there's nothing in there that says it has to be package managed.
Right. Well, I mean, the difference between a tarball and a package is really just a manifest, right?
One of the things I really liked when I got into Lava was the overlay FS approach. And that's, but not everything supports overlay FS, but that's another, idea for how to handle the read-only file system or whatever.
Okay.
We actually looked at that quite recently because we had this exact problem. The problem with overlay FS and using that to modify the root file system is that you're modifying the root file system. So what you're testing is no longer what you think you're testing. So because before that we on the device installed extra packages, but extra packages might come with extra tools or extra libraries or change behavior of the system. So we really don't want to change /user. Keep that as pristine as possible, so we know what we're testing, and the test suite is actually running against what we think is on the production device in /user, rather than something else.
So the overlay FS is actually not touching user. It's just bringing over kind of the test runner, the test definitions git. Yes, but now in AGL we are not using like NFS. We are actually using NBD, which is we cannot modify the file system upfront.
So what I was thinking when you said overlay FS is that you're overlaying over an existing portion of your file system, not necessarily creating a different file system space. That's of course fine, and essentially what we do as well.
Okay. I mean, but it's a valid point because you want to test the production file system. You don't want to test the kind of modified one.
Right.
So having a good standard procedure that works like on a read-only system, production system, makes sense.
I mean, p-test is one part of what we do with testing with the Octo project. It's not going to solve all, I think when I filled in the form... Well, right now
we're talking about build artifacts. So.
Right, yeah. But it is certainly one mechanism of doing that. It's not going to cover all of the different use cases. Right. And certainly, one of the reasons I mentioned dependencies earlier, when I was talking about that, I was specifically meaning software dependencies. Because as you say, the more you pull into the system, the more you change it, and then the more it's different to what you're testing.
Wait, I got to write that down. So you're talking about the software dependencies for your build stage on the p-test stuff?
Yes. Okay. Yeah, because our p-test packages have their own sets of dependencies. And
runtime dependencies.
Well, no, those are different, right? So there's the runtime dependencies when you're on DUT, but he actually builds the p-test materials, right? So
right. Well,
so you have a build time dependency.
There's two sets of dependencies there. Yeah.
Isn't that already slightly solved by likes of Yocto and how Debian does it?
Yeah, we have that
packaging does it.
Yeah, we have that problem figured out, but it's still something where you can end up making big changes because you pull that p-test package in, or even when you're building the system, you have to make changes.
Yeah, you don't want to pull in dependencies.
So I want to veer off a little bit and talk about, I think, the kernel CI model for build artifacts. So on the diagram, we've got this thing, and I think you guys do it differently than. I know you do it differently than Fuego, right? So because we have Fuego, like this whole diagram is in one Docker container, right? So we have the luxury of close interfaces between a bunch of our components. But one of the questions I had, well, just describe the kernel CI flow around build artifacts, I guess.
I mean, kernel CI, what it does is it monitors a bunch of kernel developer Git trees. It builds the kernels and dumps them all in one big repo. I mean, that's the
But it's a
TLDR version.
it's a worldwide repo, right? So you have
Yeah.
a central repository for all of your build artifacts.
Well, it just happens to be that everything runs on the same machine, so that all gets dumped in one spot.
Okay.
But that's not scaling either, because we don't have enough storage to keep everything, so we throw it away after a while. But in terms of build artifacts, I mean, basically we just push kernel images. We build modules with the kernel, so we push a tarball of modules, and we push the config file, and like the symbols. I think we still push the symbols map, the system.map, a couple other things
okay.
like, and then we have some. Then we push a little JSON with some metadata, like the kernel image size, the host architecture, the cross compiler that was used, how long it took to build, you know, how many cores and stuff, because we're tracking build performance. And so there's a handful of just metadata in addition to the artifacts that get pushed. That all just gets dumped into a file system on a storage server. Only some of that eventually ever gets used in the test. Like,
right.
You were talking about the config file. We actually build the kernel and push the config file, but the test has no way of knowing where that is. So we still depend on like proc config gz if the test really wants to know that. We don't really have a standard way of passing that down to the test either.
Okay.
But yeah, that's basically what kernel CI does. It just
So, and one of the things is, well, this maybe this takes us into interface E, which is the next discussion topic. But so, what is the is this lava? Is E lava for you?
no, the big kind of gray box on the right hand side is a combination of lava master and a lava slave for most kernel CI labs. So kernel CI actually doesn't depend on lava. It just happens to be that most people that set up labs that use kernel CI use lava.
Okay.
So what is that J on the top middle arrow?
This one?
Yeah.
No, that's
E.
E.
That's E.
E.
So what E is in kernel CI is the green box takes those artifacts, the kernel image, the device trees, the modules and stuff like that, creates a lava test definition, which is a YAML file, and spits it. So that E line basically is a Lava API.
Is that a common method in Lava to create the YAML file on the fly?
Well, the Lava...
Or is it just because it has some dynamic fields?
No, Lava definitions are YAML. Lava test jobs are YAML files. So it just happens to be the format that was chosen.
Okay.
But
so that's just essentially part of the API.
Yeah, but if you look at it, what you see is you see a field called kernel with a URL to where the kernel image is in the story, and you see and you see a DTB, and you see a modules, and you see a few other things, and they're just a list of URLs. So
does kernel CI do like test LTP? I mean, what if you're running an LTP test, assuming you do, I mean, how does that relate to this stuff?
So that's also the thing that spits out those test job definitions. The default way is just a boot test, so just a kernel image, and then boot that on the devices. What are all the devices that it can find essentially? So there's a whole bunch of labs, and it just finds it sends a pile of jobs to all the different labs, and if they can test them, they test them. So there's a baseline testing on it, and as many boards as possible is just a boot test. But then there are test plans for LTP and actually some DRM and V4L2 and a handful of kind of small test suites, and those are also the same thing. Those are just spit out as Lava jobs that after they boot, they also have a test plan.
Okay, but you're not. Are you building LTP, or are you expected on target already?
No, there's not expected on target. The tests themselves are on target, but they get there in various ways. So that's also the test definition says here's a URL to where my tests are, or here's a Git repo where my tests are, and Lava will fetch those and package them up in the ways of the target that they get on target. Okay. So Lava actually takes care of. There's various ways Lava can do it, but you define in your test definition, here's the URLs for my test packages. Here's the script essentially that I'm going to run.
But by the time Lava gets it, they've all been built. So is the building outside of Lava?
That's the building of the tests.
You can build on target as well.
So are you building LTP? Is there? I guess my simpler question: is there an LTP binary here in the build artifact?
Yes, I mean there's rootfs images that have
rootfs images that have LTP in it.
Yeah.
Oh, okay. So that's not a
But it's-
separate thing.
But actually,
It's
that's
not bundled.
this is where
Yeah.
Lava is weird, because Lava essentially lets you do this many different ways. So you can have them in the root file system, or you can have a Lava job that says, here's where my test binaries are.
Oh, so it could
When
be a completely separate repository.
Yeah. And when it
just-
gets to the
okay.
target, or when it gets to the Lava dispatcher might go out and fetch those for you and package them up and put them in your root file system. Or you can also say, I'm actually going to wait till it gets all the way to the device under test, and the device under test is going to go fetch those and build them and run
Yeah,
them.
that blows my mind.
So that's there. I mean, it allows you to do this in many different ways.
I know that's one of the problems with getting Fuego to integrate with Lava.
From
is
a kernel CI perspective, we don't care about any of that stuff. We don't want to care about any of that stuff. We just want to, kind of like Richard was saying, what we want is a generic way to spit off all these tests and collect the results when they're done. If it's p-test, if it's LTP, whatever, it doesn't really matter.
Right.
It just happens to be that the Lava has many flexible ways of doing that, so that's what most labs are doing.
Yeah. Okay.
I would just clarify one thing. So what Kevin calls test definition, I would call a test plan rather than definition.
plan.
I'm sorry, test what?
So what Kevin calls a test definition, I would call a test plan, because definition, at least in my understanding, is for one test, and it defines how to run this test. And you put a couple of them together and send towards the device, and this is our test plan.
Okay.
Yeah, actually, we call it test plan too in kernel CI. I just screwed up the terminology because I didn't study the glossary enough.
Okay, so I guess, okay, what are the bundle formats? I mean, when I talked about tarballs, what is a PTS, or I mean, what is a p-test bundle format?
For us, it's the package system that's being used on the target device, so it would be an RPM,
Oh.
an IPK, or a DEB.
Oh,
But
so
it
you
could,
support 3, huh? Of course.
yeah. Well, to us, it doesn't matter. It's a standard package.
Right,
but,
standard
but
package.
if you had a tarball sort of system, now it's a tarball with dependencies.
Well, if you've
effectively.
already got an abstraction for packages, then that's like no sweat, right?
Right.
So, okay. What do other people do? Does 0 day? Oh, well, go ahead.
Yeah, sure. So basically, in 0 day, we have we use the CPIL tool to compress the output to the CGZ format.
Okay.
Basically, we will try to reuse the build artifacts like the test binary or the test dependency. So finally, we can use it to become part of the init-rem FS. Yeah, so it combined with the basic root FS. So we finally run the test on the test target.
So is 0 day, sorry, this is kind of off the topic, but
Yeah,
is
sure.
0 day running completely on virtualized?
Both,
Do you do
yeah.
any hardware?
Yeah, both. Yeah.
Oh, you have both. Okay.
Yeah, but for the virtualization, for the virtual machine, it's more suitable for boot testing.
Right.
Also, we find out that some functionality testing can be run the VM also. But for the one that is not suitable on the VM, like the benchmarking,
Yeah,
so we
benchmarking.
use the server with the physical ones.
Okay. So okay, I don't want to get on a sidetrack. Okay, so basically it's a CPIO, and you can either load it separately or have it built into the init.
Yeah, actually we also have multiple ways to do this. Basically, we have some base root FS, like from Debian, from Ubuntu, from Fedora. So these are try to make them as generic as possible for various test suites. So we only install very limited packages for them. And then for each test suite.
So do you make them into like a .deb, or do you format is your bundle, do you format it into like a Debian package, a .deb file?
No.
Oh, okay.
Yeah. Then for the test suite, we will first try to build the binary ourselves for different root FS. And then we also need to figure out the runtime dependency for each test suite. So we will have the base root FS, then we have test suite binary, then have dependency binary, and plus the kernel. So when we run the test, we will combine all these things together in the init-rem FS and to run.
Okay, so I thought I heard you say you have a dependency binary?
Yeah.
So do you have a program that runs on the target that checks dependencies?
We do it when we build the test binary. Yeah, so we have some kind of test dependency definition. So we will know what are the required packages for a certain test suite during the runtime. So we will leverage the apt bundle utility to figure out what are the files we need to install.
Okay, so you're not talking about a program that detects the dependencies, but the programs that fulfill the dependencies, like extra materials like TCP or I don't know. Okay.
Yeah.
Okay.
So and then for the test suite that is very complex, like the Phoronix. So we cannot build the dependency as a separate binary. So what we do is we have 4 rootfs which install all the dependencies, and then we use the overlay fs when we run in the test. So all the generated the test output, they will not impact the rootfs. Then we get the output back.
Okay. Okay. Okay, so I'm not sure exactly where to go from here. I don't know if we have action items. There's some similarities, but I don't know. Do you have any?
I think for the test definitions, it would be a good first step to just collect all the different Git repositories on the wiki, so one can take a look how the other projects are doing that and identify similarities.
Yeah, one idea I had was to start, and I did this for Phoronix on their test survey. I actually went and I looked at their test definition, and I listed out all the fields. And so maybe just start with a field comparison and see what are the commonalities. And again, we don't have to actually go change our field definitions if there's a way to interchange between them, as long as things don't have wildly different kind of meanings or something. We may be able to interoperate. And so I think that, okay, thank you very much. Lunch is ready. That gives us, according to my thing, we've got 5 minutes to figure out the test execution API. Which this is a small topic, so it probably won't take that long. No, actually, we don't have time for this. So let me, I'm not sure what we want to do. Do we want to not do this at all, or come back to this after lunch, or make that decision after lunch? I don't know. What do you think?
Maybe you need to define what text execution API
well,
is for.
it's API E,
right, yeah.
Listed on this diagram right here. It's between the test manager and the lab. So I'm not sure. In Lava, it's what you were just describing in Lava, right? For Fuego, these things are so close together. For us, it's really, we have a single executor that's a Python. Well, it's actually, a lot of it's in shell, but portions in Python, some in shell, that executes the steps, right, the build phases. And one of the phases is check dependencies. One of the phases is build. One of the phases is, I essentially would be provisioning.
It might be useful to think about it in Yocto terms, in terms of the phases, because it's essentially like the fetch and the deploy.
Right.
And
well, we have the same thing. We have fetch, deploy,
right.
Run.
Yeah. So just having that list of phases might be the good starting point.
Okay. Well, should we do that after lunch? I think it's worthwhile to work on this, but here's the reason I don't want to spend the time right now, is because here it is. Lunch, 12:30 to 2. It's located. I have no idea where it's located, out there somewhere.
It's not here.
But here's the deal. So we're being sponsored by the Core Embedded Linux project. Some of you are involved in the embedded field. And what we'd like to do is so we've got an hour and a half for lunch. If you would like to, if you're interested, we'd like to invite you to come back here, bring your lunch back here, or if you're done in a half hour, just come back. And we want to have a little bit of a brainstorming on the status of the embedded industry. So we thought we'd sneak that in while we're having a discussion on testing, right? So if your thing is only test, or you're testing enterprise stuff and this doesn't relate to you at all, go have lunch and take a break. But if you But I know some of us have been in the industry for a while and we're kind of interested in what's going on. What we'd like to do is kind of discuss the current status of embedded Linux and talk about possible projects that might be interesting for the Linux Foundation to fund. And so if you're interested in that, please either come back at 12:30, and if you bring your lunch, that's fine. You can eat it in here. But other than that, I think what I'd like to do in terms of what we were just talking about is I would like to pick this back up, although we'll have to, we'll think about during the lunch how much time we have to spend on it. I don't think we have a lot of time, but maybe we can do, like you said, just go through the phases real quick and talk about that execution API. There's multiple aspects to the API, right? Is it a remote API? Is it a local API? What are the steps? So, but anyway, okay. Sorry, that's kind of a end on a whimper, not a bang, but so let's go ahead and take a break for lunch, and I'll see you, some of you back in a half hour and some of you